Dear friends, Happy New Year, good afternoon, and it's 2nd January. We start the program for my YouTube channel for 2022. The starting program is about the book shopping I did in Calcutta. Calcutta still remains the megalopolis of the mind, not to that extent which I saw when I was a child or a student there, but it's to a large extent it still remains. And one of the places that I like to visit when I go to Calcutta is College Street, and there is a bookstore called the Sarat Book House, which was established by a physics professor of Vidyasagar College under Calcutta University, and that is possibly the finest science bookshop of this country. And there is a huge collection of Dover books. Dover Publications is a US publication who publishes old books, but important books which are still relevant today. For example, you will get books written by Euler or Fourier, or books written in the 1970s, 80s, but still very important today. So, I bought 6 books, of which one is for my research and others are for my channel for education, right. So, I will just show you my shopping. So, you can say that was a kind of a Christmas or New Year shopping. So, that kind of shopping that I did every time I visit Calcutta or Kolkata, if you want to call it by the correct name, then I would always go to that shop and get 1, 2, 3 books, but this time I did a large amount of shopping. I think I am very pleased with that. So, maybe just I want to share with you to start the year, and then we will I will tell you what were my next program. And so, let us start with 2 calculus books. One is the basic calculus, one is advanced calculus. Here is a book written by Richard A. Silverman. Richard A. Silverman is a very famous author, especially in the form of translation. He is someone who translated mathematical texts in Russian to English and published them in Dover books. This book is a very good book because it consists not only starts with not only basic things like basic things about one variable calculus written in a very detailed way, but and with lot of applications, but it goes also in at the end to function of more than one variables, talks about partial derivatives and all those things, but that is very less, but largely it is function of one variable and lot of applications. See, function of one variable is very important because, for example, if you have a curve, so at every time you are observing a particle moving along that curve, right. At every time t you are making an observation. So, at a given time t, it is at some coordinate which is dependent on that time t. So, that is x t, y t and z t in 3 dimensions. Now, if you want to know the speed or the velocity at which it is going, then you need to take the derivatives of x t, y t and z t. So, you just know about function of one variable, which is t, the time variable, and by doing so you can study things in higher dimension which are happening in higher dimension. So, look at that is the power of calculus, that knowing about only functions of one variable, you look at things which are happening not just on the real line, but in higher dimensions. So, those kind of things are there in this book, and then I would bring your attention to Anwar Friedman. Anwar Friedman is a famous mathematician and has written several books even on functional analysis, and this is a book on advanced calculus. So, here he starts first with advanced calculus and real analysis are almost same thing, maybe this or that topic taken off and taken in. And so, here he starts with basic one variable calculus, and very soon skips into he talks about everything, sequence, series, whatever you want to say. And for example, here is a chapter on sequence and series of functions, and then he skips very fast into functions of more than one variable, and here he does a hugely good job. And I would say that this part is very well written, function of more than one variable. For example, he gives the details about inverse function theorem, here it talks about inverse mappings, right. And this is all published by Dover. And what this book has, which other book does not have, is a chapter 10, which is called selected topics. So, what is selected topics? Selected topics means there are certain things which are not usually found in text, but are given here. For example, the Euler's summation formula, for example, the Stirling's formula for n factorial, that n factorial can be approximated by n divided by epsilon e, and e is exponential to the power n into root 2 pi into n. So, these kind of asymptotics, these are called asymptotics, almost equal. So, that is the limit of n factorial by this number as n tends to infinity would be 1. So, in limitingly equal. So, that kind of ideas are studied here, like asymptotic series, and then also comes to. So, here he talks about Fourier series, which is pretty detailed, and that's about it. And obviously, he talks about harmonic functions, partial differential equations, and more about divergence theorem and how to handle ordinary differential equations and some aspects of PD, partial differential equations. The book that I actually loved buying and enjoyed looking into as a mathematics researcher and educator is this book, Theory and Applications of Infinite Series. I have been hearing about this book for a long time, and it has, I think this was first into parts, first part it talks about sequence, second about series, and about complex series. Now they have made it into one part possibly. This is given by Konrad Knopp, who is I think a mathematician based in, I will just look at him, where he was based in Netherlands. So, Konrad Knopp. So, he has also a book on the complex function theory they used to call. So, it just does not talk about infinite series, it starts with real numbers, it talks with sequence, it talks about series, it talks about Fourier series, because Fourier series is also a series, it talks about series and sequence of complex numbers, and most of the results here can be generalized for a large number of them for sequence in higher dimensions, right. Or now, the interesting things that happen here, which is that there are many results which are given here. I had also never heard of them, never seen them. So, this is something exciting for any mathematician, math enthusiast, any educator who teaches analysis should have a look at this book. It has got all the historical details. There is some results from Cauchy's book on analysis that has been put in. So, for example, if I have a sequence x1, x2 x xn sequence which converges to some number L, then I construct a new sequence. So, whose every term is nothing but the, suppose nth term of the new sequence is the mean of the first n terms. So, x n dash is x1 plus x2 plus xn divide this whole sum divided by n. Where does this converge? Does it converge? The answer is it converges to the same limit. This of course, if you ask me, if you give this to me as a problem, I can think and of course prove it by from first principle. But these results are already known to Cauchy, and those little results. So, every nitty gritty of infinite series and sequence that was known in classical analysis. This is really a book of classical analysis, and that is present in this book. Anybody who is doing research in algorithms and optimization, where you have to use sequences a lot, actually would do very well with this book, as will have a huge amount of information. For example, there is a huge this chapter on infinite series of positive terms. There is so much information that it is amazing. So, and there is a lot of remarks, historical remarks filled with problems with which has hints have been given, and at the end, again the same Euler summation formula has been discussed. There is a whole discussion on divergent series, which is very unlikely for standard books. So, these talks about what happens about series of complex numbers. Of course, when you study complex analysis, you learn them, but here the details are fantastic. When every special type of functions or special type of series is dealt in detail, and the information you have is amazing, and the writing is absolutely modern. Anybody who studies modern analysis would know what it is, and those who are afraid of epsilon delta description of convergence of sequence would really know it very well if they study this book. Again, I want to show it. I am pretty happy to have this book, because he starts with a concept called null sequence. Essentially, what do you mean geometrically when a sequence approaches 0? It means that its distance from 0 should decrease as n becomes larger and larger. That is it. So, mod of x n, give me any distance that you think you want to check from 0. I would for n sufficiently large, I would have mod of x n for all n beyond certain n to be less than that epsilon, that distance. You make it more smaller, for more higher n's I would have x n coming towards, the distance from 0 would be less than that number. That is the meaning of something approaching 0. Now, when I say x n is converging to L, what I have to show is that x n minus L is a null sequence or a sequence converging to 0. So, once you know what you mean by a sequence of numbers converging to 0, all this epsilon delta game that people are afraid of actually becomes very simple. That is the story. Now comes a book which I think engineers should actually have a look. This book is by George P. Tolstoy, a Russian mathematician, this book on Fourier series, and it is translated from Russian by Richard A. Silverman. I hope I am able to show you this properly. I think the light is little less, but this is done by Richard A. Silverman. So, this guy Silverman has done a lot of translations, including book of Kolmogorov and Fomin. So, if you look at this book is one of the finest books written on the fundamentals of Fourier series. It starts with what is a periodic function, talks about the convergence of that infinite series, and every proof is given in a very, very detailed way. There is no hanky panky or the say, oh, this is obvious, prove it for yourself. It is nothing like that. Every step has been very clearly chalked out. So, to learn Fourier series, I would really recommend especially engineers and also mathematicians to have a look at this book. Of course, this book was actually originally published in 1962, but that does not mean that the contents here has no meaning, right. So, because a lot of things have happened in Fourier series for which there are modern textbooks, but there have been a lot of applications and a lot of theoretical development in Fourier series, a vast subject. This is really the start of real analysis. So, real analysis was largely built up, it came out as a subject to handle things like Fourier series. So, Fourier series is historically very important for analysis. So, if somebody tells me to teach Fourier series, I would actually go and teach from this book. Very nice, very beautiful problems given, everything is done stepwise. So, you do not have to really wonder what is happening, everything is done absolutely stepwise, right. Everything is done stepwise, so you do not have to wonder what is happening. So, this book is a recommended must, Fourier series by Joydeep P. Tolstoy. And here comes a very unique book. I have never ever seen a book like this on multidimensional calculus or calculus of more than one variable. It takes a very differential geometric approach. It is by Marshall Evans Munro. I have never heard of him, to be very frank with you. Let me just figure out where is Marshall Evans Munro from, somebody from United States, I guess. It is a second year calculus course. He is from Durham, New Haven. So, just let me figure out what it is a second year calculus course. So, this book is just fabulous in the sense that it takes a completely different viewpoint of what a very modern viewpoint. It starts by talking about differentials for functions of one variable, then goes into the study of surfaces, because functions of two variables represent surfaces, and talks about them from the point of view of manifolds, because surfaces are two dimensional manifolds. And this then has a huge description about handling continuity, Lagrange multiplier rules, differentiation of functions of many variables or two variables, but takes in a very linear algebraic view. Matrices play a very fundamental role, including orthogonal matrices, rotation matrices. So, this is the kind of thing which is very unique, and in it has a huge section on multiple integrals, and does it in huge detail, shows a lot of applications, and also takes it handles differential forms, which is very unlikely in standard calculus of many variable books, because it gives you several results in differential geometry. So, it integrates differential geometry or manifold theory along with calculus of more than one variable and linear algebra in a sense that once you have studied this book, you can study books on manifolds, you can study books on differential geometry. A lot of things can be studied once you have learnt this book. So, this book maybe I will take up sometimes to get some information from this book, share it with you, but not for now. So, for example, I would again just tell you about this book, Anwar Friedman's Advanced Calculus. This book has a lot of what should I say, a lot of beautiful explanations. Specifically, it has a fantastic proof and explanation about implicit function theorem, which is extremely fundamental in writing the Lagrange multiplier rule that you study in calculus. So, that is minimizing of function f, differential function f over x, which satisfies for where the decision variable x satisfies one or more than one equality constraints, which are also differentiable, continuously differentiable rather, smooth. The sixth book is absolutely for researchers in optimization, Calculus of Variations Application by George C. Ewing, who was an expert in optimization and calculus of variations. This is also an old book, but it has huge materials which can be only profitably used by someone who has a lot of experience in doing optimization research, because it starts from very basic and goes to pretty advanced levels. And so, I would never recommend even a graduate student, means a PhD student, to study this book if he wants to study calculus of variations. There are other books which he can profitably study. So, if one wants to get into more higher details about the research in optimal control, like non-smooth optimal control or non-smooth calculus of variations, then this is the book a researcher has to first look into and then take a jump. It talks about like Tonelli's direct methods and all those things, which are very unique and not really found in other calculus books. George C. Ewing is known in the optimization community of static optimization for introducing a concept called semi-convex functions, and he had applied them to the study of calculus of variations. In fact, I had my paper, his paper here somewhere in my desk. That is kind of very nice actually. So, this is a book actually for researchers, and I would not recommend this book for anybody else, but any optimization researcher who is into this field can really should have a look actually. So, thank you very much. My next program, I will make a pre-announcement, is that there is this fantastic book. I have never seen a linear algebra book so beautiful. Linear Algebra Done Right by Sheldon Axler, and I am going to do a review of this book. Okay, and the two programs that will come after this is a review of this book as well as a review of this book, Linear Algebra Done Right for Everyone by Gilbert Strang. So, these two books will be reviewed in my next program, which will be slightly large, but this book, Linear Algebra Done Right, looks at linear algebra not from just from the point of view of matrices, but from the point of view of linear operators, and it is basically a second course in linear algebra, good for math major student. I would love to teach a full undergrad course or math major student course for math majors or even others, does not matter, with this book. It is so beautifully written, beautifully described, the history given, all the theorems beautifully proved, fantastically interesting problem. The author needs to be really congratulated for what he has done. A fantastic, fantastic job. I think there isn't any book in the market right now to challenge this book. So, thank you. Have a nice evening. It's cold out here, and I hope wherever you are enjoying this start of the new year. Hope that you will all be safe and COVID won't be able to do any harm to you. Thank you so much. Thank you very much.